All right, this is section 6.2, degree conversion. So the first thing we're going to do is talk about two ways to measure angles. The first way we did yesterday, or the last time in 6.1, was in degrees. Pretty much we know how to do degrees and so forth. But the second way we're going to talk about is in what we call radians. Okay. Radians means I'm in terms of pi. So in other words, I'll have, instead of an x, and when we say in terms of x, we have 4x, 5x, 6x. Instead of that, we'll have 5 pi, 6 pi, and 7 pi, and so forth. So that means in terms of pi. So radians is just another way of that we measure angles. And so if you remember from your back in geometry, I'll just kind of draw a picture over here. Here's my measure and here's my circle. And so when we talk about radians, we talk about the angle, like say we have this angle from here to here, okay? And so the radians is just this arc part of the circle, this part here, okay? So remember that's like the pi, we'd use circumference to figure out the length of that, but to find this angle inside here, okay, we measured it in radians in terms of pi instead of degrees when we use radians. So it's the same as like if you have 12 inches equal a foot, that's a basic conversion that you know, that kind of thing. So we're doing radians instead of degrees. So pretty much the definition of what a radians means, it's an arc, and that's why I just colored over there in black, of a circle whose length equals the radius. Again, it's just another way to measure. Okay, just another way. So I wrote all over it. So a basic conversion that we want to talk about in here. So again, like I was saying, 12 inches equals a foot. So for us in trigonometry, we say that pi equals 180 degrees. That's my basic conversion. Sorry, I ran out of room. Okay. So we're going to convert back and forth, just like you do inches to foot, foot to inches, and so forth. This time we're going to figure out how to do that. So the first one that we're going to do is that we are going to multiply, if we want to change, from radians to degrees, okay? We are going to multiply by 180 degrees over pi. So when we're converting and using this information, we want to make sure that we can tell what our degrees is and what our pi looks like. And so for our units of measure, so that little degree symbol is important now. So be careful with that. So when we're going to do this is the same simple thing, and I want you to just think about multiplying fractions when you do this. So if I want to convert pi radians, that's pi over 2, pi divided by 2 radians, that's how we read it, 2 degrees. All I'm going to do is take my pi over 2, and I'm going to multiply by 180 degrees divided by pi. Now when we get done, if I'm looking for degrees, I should have no pi's. So think of your fractions. I can cancel, I can cancel the top and the bottom is the same. So this pi cancels with this pi, goes to 1. And I can also cancel the 2 and 180. I can 2 divided by 2 is 1. 180 degrees divided by 2 is 90 degrees. So multiply bottom, top. So all I have left is 90 degrees. So pi over 2 radians is equal to 90 degrees. So that's a conversion you will have to memorize. I'm going to circle that. Okay. So let's do the next one. Same thing. I'm going to go over to number 3. The way it's my thing is set up is much easier. I'm going to take pi over 8 times 180 degrees divided by pi. Again, cancel what I can top and bottom by reducing those fractions. So I can cancel out pi's because I can divide both by a pi. Gives me a 1. And then however you convert. You don't get a calculator, so however you can cancel and so forth. Sorry, let me convert. Cancel, so I'm just going to go by, 2's first. So 8 divided by 2 is 4. 180 degrees divided by 2 is 90 degrees. So I'm just going to simplify over here. I won't do this every time, but whatever way is easiest for you to do to simplify, then I would just do that. So now I know I can divide those both by 2. So 90 degrees divided by 2 is 45 degrees, and 4 divided by 2 is 2. So 45 divided by 2 is going to be 22.5 degrees. So pi over 8 radians is equal to 22.5 degrees. Okay, so I went ahead and did these two problems. Again, so 7 pi over 9 radians is equal to 140 degrees, and then 3 pi over 4 radians equals 135 degrees. And we kind of, leave off the word radians when we read the first, like 3 pi over 4 radians. We have a tendency to say 3 pi over 4. Just know that's how you read it, and so when you see it written that way, you understand. Each of these should also have that degree symbol in there. It's very important that you notice that because we are converting back and forth. Okay, so let's go and convert the other way. We're going to change degrees to radians, and so what we'll do here is we will multiply by that reciprocal of 180 degrees over pi. So we're going to do pi divided by 180 degrees. Okay, so let's do the first conversion. Move this up a little bit. All right, so I'm going to have 50 degrees. Now I want pi, but I don't want any degrees. Okay, so when I write 50 degrees, again, writing the symbol times my pi over 180. And the degrees does disappear here. It does cancel out because I put this over 1, fraction, multiply, cancel top and bottom. This degree right here cancels with that degree. So the degrees just do disappear, and that's how it works. So now I'm going to reduce this fraction. So 50 divided by 10 is 5. 180 divided by 10 is 18. And so I'm left with 5 pi over 18. No degrees, and I'm left with a pi in there. So it's 5 pi over 18 radians. Okay, so 5 pi or 5/18 pi radians, different ways you can read it, but that is that solution there. Okay, let's do the next one. 210 degrees. So I'm going to take 210 degrees. I'm going to multiply by the pi over 180. Remember, when you're done here, you do have pi, so make sure you have that in there. So this degree canceled this degree. I put this over 1, and I'm going to reduce this by 10 again. So this is going to be divided by 10, 21. This divided by 10 is 18. And that leaves me with 21 pi over 18. And then I can keep reducing that 21 and 18. If I divide by 3, I am left with 7 over 6. So 210 degrees is same as 7 pi over 6. This is one you have to know as well. I've memorized. Okay, let's do, I'm going to have stop the video and you do the other two. Okay, for the last two, number 2, I got 3 pi over 4. Again, circle that one, you have to know. And then 360 degrees, the same as 2 pi radians. And you have to know that as well. So again, please make sure your pi's look like pi's. You can try to be a little fancy and do the little curly or Q with it when it does that. But doing straight across like that, as long as I can tell it's a pi and not 11 or, a plus sign or a hash, whatever, as long as it looks like a pi. Okay, so I'll just kind of move that over a little bit. So I just redrew this this axis here. And so what I want to do is I want you to draw this on there, and I want you to now go back and label the axes, but this time with radians as well. Okay, 90 degrees, same as pi over 2 radians. 180 degrees, we said the basic conversion of that was pi. Now 270 degrees, so if we go over here, 270 degrees times pi over 180 degrees. There's one. We know that this can reduce to 27. This can reduce to 18. And then 27, 18, 27 can divide by 9 3 times. And then 18 divided by 9 is 2. So I wind up with 3 pi over 2. So all those you need to know, those are our axis angles, which means those are on the axis. They're not in the quadrants. They lie on the axis only. Okay? So what we're going to do here is talk about kind of like we did yesterday, or last lesson with our 4 angles and so forth. But first, let's talk about our common angles, and this time we're going to talk about them in radians. So I just did it on the axis over there. So on the axis, so that's what this is talking about. Every 90 degrees is what it's saying, okay? So every 90 degrees, which is the same as saying every pi over 2, okay? So the first one, 0 degrees, is now 0, okay? We're not going to call it 0 degrees, it's just 0. If you put a 0 degree, if a degrees in there, in your radians, that's incorrect. 90 degrees we know now is pi over 2. 180 degrees is pi. 270 degrees is 3 pi over 2 radians. And then 360 is 2 pi radians. Okay, so now, based on what we did, these are our quadrant ones. These are our reference angles. Number quadrant 1 are reference angles. And these are the ones we're going to use. Now we're going to convert these into radians. Well, if you think about it, if I just take 30 degrees times pi over 180, all I'm saying is, what's this reduced to? Remember, these are fractions. So this is going to reduce to, and I'm going to give them specific colors like I did on the last one, but might not be the same color, but I'm going to give them 3 different colors, okay? So for 30 degrees, I'm going to use blue, and that's pi over 6. Okay, 45 degrees, okay? So you're kind of going to eventually figure out that, so you're going to see eventually, just after doing it over and over, because you don't get a calculator, that 180 degrees divided by 4 is 45. So when you reduce these, it's going to just be pi over 4. Okay. And then my last one, 60 degrees. Well, if you think of one's 30, one's 60, and one thing if you kind of think about, pi is 180 degrees. If I divide it by pi by 30 or 60, I'm going to get those opposite things. So pi over 3 is 60 degrees. Okay, so those are our reference angles, okay? All right, and so we're going to use those to do the same thing we did earlier in using our 4 quadrants. Okay, same thing that we did before. We're going to go through each of these quadrants, determine what the angles, reference angles are in relationship to the actual angle. We can kind of use what we did before to help us define this, which is kind of nice because we already have these angles down if you look at 6.1 notes, okay? So the first thing we're going to look at is the reference angles. The reference angles do not change, okay? Remember, if they're in quadrant 1, they will be reference angles. So this is quadrant 1. So again, think of this as pi over 2, and this is 0, okay? So our first reference angle, and I said I was going to use different color specific ones. So the smaller angle here, okay, is going to be my pi over 6. The one in between will always be pi over 4, 45 degrees. And the angle that is left over is from here to here. My reference angle is going to be pi over 3. Okay, think of pi over 3. Kind of help you too. The smaller, the larger the number underneath the fraction, the smaller the number. Okay, so now we're going to go look at what we had before. And what we're going to do is we're going to look at the same kind of idea. This tells us that if we do quadrant 2, we have the pi, and we subtract the reference angle. Well, I know the reference angle, okay, so I figured those out. We discussed those, okay. So what we're going to do is we're going to figure out what those actual angles are in radians. Okay. All right, so the first one we're going to look at, again, I'm going to look at this side going from here to here. Okay, this, remember, again, you're talking about the angle here that's left over from when we went around to subtracting from this 180 degrees here. Okay, this is your axis here. This is pi over 2, and not, pi, I apologize. Up here is pi over 2, so this angle came around from here, around here. What's my reference angle? What's the difference between that angle and the axis? Okay, so I'm just going to get rid of all this extra writing that I've done. So what we're going to do is we're just going to find that by using math. And I want you to think of subtracting fractions. I want you to think of pi as a variable, like I said before. It is a variable. We are not, you don't have to change it. It doesn't be written anything else. It's going to stay that way, like it's an x, okay? So we know the reference angle here is pi over 3. Okay, that's our reference angle. So now what's the angle itself? Okay, so what we need to do is we need to take 180, which is pi, minus the reference angle. That's what's telling me right here, which is pi over 3. Find a common denominator between those two. Common denominator would be 3, so I'm going to multiply top and bottom by 3 to get 3 pi over 3, and I'm supposed to subtract the pi over 3. Well, 3 pi's minus a pi is just 2 pi's, and the denominator stays the same. So now my angle right here that I have right here with the reference angle is 2 pi over 3. So that's that angle, okay? The reference angle is this. It's in green. That's the pi over 3. The angle itself coming from around to the second quadrant is that one. Okay, let's do the middle one. The middle one we're going to do is think of this one, from this one. My reference angle is pi over 4. So same thing, pi minus pi over 4. I'm just doing what that tells me to do. I need to multiply top and bottom by 4 over here to get a common denominator. When I subtract those 4 pi minus pi is 3 pi over 4. So that's that angle. Okay, last one. Our middle one in here, a little one. Okay, our reference angle is pi over 6. Again, we're going to take 4 pi, we're going to take pi over 1 minus 8 pi over 6. And what do we get? Well, we have to change that to 6 pi over 6 minus pi over 6, which leaves us with 5 pi over 6. Okay, so those angles are from there. Now again, I'm getting these angles based on what we did before. This is the smaller angle between the x-axis to that angle, okay? So that's how I'm finding which one I'm doing. Okay, so let's go on to the next quadrants. Okay, quadrant 3. This tells us to add pi to the reference angle. Okay. So again, I'm going to think of this right here as this is my axis, so this is pi. Okay, down here is our 270 or 3 pi over 2. Okay, all right. So again, when I'm coming around from over here, what are these angles going to be? Okay, I'm going to find by using my reference angles, and I know by my reference angles based on what the size of what they look like. So if this is the smaller angle here, this first one, okay, that's going to be my pi over 6 as my reference angle. So reference angle is pi over 6. So this time I'm adding pi to the reference angle instead of subtracting like I was doing earlier. So start here. If I have pi and I'm adding pi over 6, so one thing nice about already having this done, it's the same as this over here, but instead of subtracting, we will add. So I have 6 pi, so I'll just rewrite it, over 6 plus pi over 6, which gives me my 7 pi over 6. So here I'm going to have my angle as 7 pi over 6. Okay, my next angle is going to be from here to here. That is the reference angle of pi over 4. Again, same thing I have over there. I can say I have 4 pi over 4 plus pi over 4. And so that is going to give me 5 pi over 4. Next one, then here. Okay, so we have, this is reference angle for us here is pi over 3. So I had 3 pi over 3 plus pi over 3. So this angle is 4 pi over 3. All right, let's do the last quadrant. Okay, so now our last quadrant, quadrant 4. Okay, we have 2 pi minus reference angle. Okay, so this is going to be our 2 pi, not at 0. And this is going to be our 3 pi over 2, 270 degrees, that's 360. And the same thing we'll do is we'll just have to tell us what the reference angle and go and determine the angle itself. All right, so the first one we'll do is the bigger one because that's what's, we're going to come to this angle here, right here. So this is our outside, or I mean our bigger one, I should say. Okay, so that reference angle is going to be pi over 3. Okay, so the angle itself. Now, a little different here because we're taking 2 pi and we're subtracting the reference angle. So I'll do it over here. So if I have 2 pi minus my pi over 3, this time I have to still find a common denominator of 3, but I'm having to do maybe a little bit more work, but not really. Multiply this by 3 and this by 3. So we have 6 pi over 3 minus, sorry, write that, pi over 3. So 6 pi over 3 is going to give me an angle of 5 pi over 3. Okay, the next one, reference angle from here to here. Is pi over 4. So this time I'm going to do 2 pi minus pi over 4. So if I multiply it by 4 and a 4, I'll get 8 pi over 4 minus pi over 4, which gives me 7 pi over 4. Okay, our last one, it's a smaller angle. This is our pi over 6 reference angle. So we're going to take 2 pi 1 minus pi over 6. This time we'll multiply that by a 6. So this will give us 12 pi over 6 minus pi over 6, which gives us 11 pi over 6. Again, be careful. Okay, so now those are our angles with their reference angles for each of these, this circle itself, okay, or this part of the circle. So now what we're going to do is we're going to look at what we have from 6.1 with 6.2. So the first part of 6.1, we did all these quadrants in degrees, and we found them. And now we did them in radians. So now we're going to put them together. And all of these you have to know. This entire page with the quadrants, the angles, radians, everything, okay? You're going to have to know them quickly. If I say 120 degrees, you should be able to automatically tell me pretty quick what it is in radians and so forth. So here's what we do. So we're just going to look at what we have. So quadrant 2, our first angle is 120 degrees. And so all I'm going to do is just take those angles that are up there. So I'm telling you that 120 degrees is the same as 2 pi over 3 radians, okay? And then I'm just going to do them in the color that I have up there. So this is 2 pi over 3 radians, okay? Quadrant 2, the pi over 4, it's 135 degrees. So, and you can compare this back and forth with your other 6.2 page and fill it in, and then come back and check your work. Okay, so here's everything filled in, all the quadrants with their degrees and radians. Hopefully when you see this, you'll see patterns and so forth as you go through. Like automatically, I can see a pattern with these 45-degree angles here, and I just noticed that that when you look at it, these are all odds, 3, 5, 7. The other page, you'll see that if I talk about that. So if I look at the radians, here's the radian denominator, but then this numerator is minus 1. 3 minus 2 is 1. You still have that pi over 3 here, okay? So therefore you just know 2 times pi over 3. So the next one, if I look at the, let me do a highlight, I think it's a little better. Let's look at this here, a 4, and this is a 3. 4 minus 3 gives you, 4 minus 1 gives you this 3. Over here, 6 minus 1 gives you this 5, okay? So that's for that quadrant, right? So I'm going to go back here. Quadrant 3. Oops. Let's look at here. So again, here's my denominator 6. If I add 1, I get this 7. 4, I add 1, get a 5. 3, add 1, get this 4. So that helps you quickly convert, okay? And the last one is going to be 2 times the denominator minus 1. So I'll put that in there just a second. Stay on this page. So what you have to do is you're going to take 2 times the denominator and you're going to subtract 1. Okay. So if I look, doesn't matter which way I go. So if I look right here, here's 3. 3 times 2 is 6. 6 minus 1 gives me this 5. Here I have a 4. 4 times 2 is 8. 8 times 8 minus 1 gives me the 7. Here I have a 6. 6 times 2 is 12. 12 minus 1 gives me 11. So again, another way to help you to... Okay, last page. How to quickly find the radian equivalent of the common angles using reference angles. This is just another pattern that you see when you look at them. Hopefully you determine that you may like it. If not, it's not necessarily something you have to know, but it's something that I feel like you should take in consideration, especially going from when you're talking about radians. Radians are fractions, and sometimes we just don't like them. So if you're looking at the first quadrant, automatically they're the same, okay? So the next one I want to look at is quadrant 2. Quadrant 2 is that when you look at it, the denominator minus 1 is what gives you that numerator. So I'm going to refer back and go to the other page. So for the third quadrant, it's going to be denominator. So it'll be the denominator plus 1. So referring back to that. Quickly recognize it, but again, not necessarily that you use it. Okay, my click helps them so far. Okay, so the next one, what we're going to do, we're going to determine the quadrant the angle lies in, give the reference angle, and then sketch the given angle in standard position. Okay, just like we did when you're sketching the graph, there's a few things that you have to do that we talked about. First, you'll label this in radians instead of degrees, since we are in that, so you still have to label your axis here. This is pi over 2. Again, this will just give you good practice on remembering what is where. Okay. You're going to sketch the graph. So if we're thinking of pi over 3, pi over 4, so we kind of like use what we did earlier. If we know if it's this is 1 less than this, then we know we're in quadrant 2. You can also go back and reference to looking at what you did earlier. You know 3 pi over 4 is the same. And sometimes being in degrees is something that we like to do compared to not. I mean, it just depends, because sometimes when we have it in degrees, we see where it is better. Okay, so 3 pi over 4 is in quadrant 2 is 135 degrees. So this is 135 degrees. Okay, so that is going to be in quadrant 2. So again, if you just the different things to kind of remember where things at depend on what's easiest for you to use. Okay, so you still have to do in standard position, so forth. So based on this picture right here, and I'm looking at quadrant 2, the circle that we want is the top right, top left. And again, we're going to refer to the reference angle. Well, the reference angle for us is pi over 4. Okay, this helps me right here. I see a pi over 4. So I know that I'm going to start. I still have to draw this position, the terminal side, initial side. It's going to come over here. It's going to come around, and you still have to draw the angles and the direction arrow. Okay. All right, 7 pi over 6. This will be in quadrant 3. Again, I'm looking at this angle to determine what which one it might degrees. So I'm going to look in degrees with it. So if I look at degrees, it's going to be 210 degrees. You can quickly convert, or you can sit there and think about by drawing it in your head or looking at your chart, whatever you need. So this is in quadrant 3. Okay, so quadrant 3. Now my reference angle is going to be pi over 6. So I'm going to draw from here to here. Here's my direction arrow. My arrows on each of those sides. And again, labeling my graph 0 to pi. 9 degrees is pi over 2. Sorry, I have a tendency to write it in degrees first. Pi and 3 pi over 2. Okay, so this is what number 3 should look like. Okay, I'm going to do the number 4 with you in negative, and then I want you to do the rest. So make sure you label everything according. Okay. Now the reference angle for this one, we can't have a negative one, so this reference angle is actually pi over 3. Remember that it's always going to be what's there. It's that simple small angle. If I go into clockwise, this actually winds up in quadrant 4. Okay. Oops. And then we're just going to graph it. Don't forget to label your, now you're going to label these as negative 2 pi. And we're going to go down this way. So negative pi over 2, negative pi, and then negative 3 pi over 2. So we're going in a negative direction, doing this. So I'm going here. I know I'm just going to this first line in a negative direction, and there is my angle. All right, you label the rest, and I'll go back and check. Okay, so this is what you should have gotten for the last two. Hopefully that you understand which way to go in there. Again, which way to go, positive, negative. Make sure you remember when you're sketching this graph, you must label all the parts that you see on here, especially if I'm grading it in order to get full credit, okay? Okay, so now, what do you notice about the reference angle and the denominator of the given angle? And every single time we did this, if you notice and pay close attention, here's the given angle, the denominator here is a 3, the reference angle is a 3, denominator here is a 6, 6. And up here we had a 4 and a 4. So hopefully you notice that they are the same. Again, another way to help you determine what your reference angle and so forth, okay? All right, lastly, we're going to find the coterminal angle to the given angle. Remember, your angle must be in the same form as the given angle, as the angle given, sorry. So for example, if you're in radians, your answer must be in radians. If you're in degrees, you must be in degrees. Okay, so if you think about what we did before, we added the angle to 360 to find the positive one, and we took the angle, subtracted 360 to find the negative one. So the way I'm just going to write just like we did before, just a little shorter. So we did angle plus or minus, and here we're going to have to do 2 pi, not 360. So if I want to find the angle here in coterminal angle, I must first take the angle and add 2 pi, and I must also take the angle and subtract 2 pi. So common denominator, we did this earlier, so I'm going to quickly do this. This is going to be 8 pi over 4. This will also be 8 pi over 4. Have to find a common denominator. So our answers will be 3 plus 8. So this is 11 pi over 4. And then 3 minus 8 is a negative pi, 5 pi over 4. Treat it as if it's an angle, okay? And those are your two coterminal angles. All right, I'm going to stop the video and you do the rest too. Okay, so those should be your two coterminal angles.